Hey everybody, Mr. Judson here. So we're working on this idea of substitution. And I've got a problem here that I see something inside parentheses. You know, square root is always something raised to the 1/2 power. So something inside parentheses raised to an exponent, so that makes me think substitution. So I'm going to start by saying, first of all, let's rewrite this. The integral from 1 to 5 of 2x minus 1 raised to the negative 1/2 times x dx. So now I'll do my substitution. I'll let u equal what's on the inside. So u is going to equal 2x minus 1, and du is going to be 2, and I just took the derivative of x. So all I need to do is just make sure I see a 2 right here. Oh, I can't make that happen, can I? I can't just move an x to the outside, because we can only move numbers to the outside of an integral. A variable has to stay there. And you can't just go, oh well, I'll just put a 2 there, and yeah, we'll just make that whole thing du. Well, we can't, because they're not the same, right? 2x dx is not the same as 2 dx. So we need to come up with a different method to use. And this method is going to be called change of variable. Now, we've been changing the variable anyway, so I don't know why all of a sudden this is called change of variable, but it is. And what it means is I need to kind of change the way we're doing things here. I am going to say in my integral that I've got u to the negative 1/2. Okay, that part's going to happen. The question is, what am I going to put in place of that x right there? And so what I need to do is I need to take this right here and solve it for x. So I'm going to move this negative 1 to the other side, and it'll become positive. So u plus 1 equals 2x. And then I'll divide by 2 so that x equals u plus 1 over 2. That's what's going to go in place of that x. All right? I'm trying to get everything in terms of u variables now. So I want to put this in place of that x variable. So let's see, I've got u plus 1 over 2. Now I still need in order to get a du in there, I still need a 2 dx. I still need that right here. So let's see, I'll put a 2 right here and a 1/2 out in front. All right, so the x became this, the 2 dx is going to become du. And there, I've got everything in terms of u values. Now, I'm going to do one more step here. See, these boundaries on my integral, my a and b values, those are in terms of x, but what I'm going to do now is I'm going to change those to u values, right? Since I'm doing everything in terms of u. What I'm going to do is I'm going to say if x equals 1, I'm going to go back to this, I'm going to plug in a 1, so I'll get 2 minus 1, that's 1. So when x equals 1, u equals 1 also. So that remains a 1. If I plug in a 5, I'm going to get 10 minus 1, that's 9. So when x equals 5, u equals 9. Now why do I do that with these values? Well, because now that everything's in terms of u, I don't have to substitute this expression back in later. Right? I'm interested in a final answer. Now, if someone said, well, I want to put the 2x minus 1 back in, and I want to just leave this as a 1 and a 5, well, that's okay, you can do that, it'll still work. This kind of cuts a step out, okay? All right, so let's solve this integral now. So let's see, first of all, I'm going to bring the 2 to the outside. Since it's in the denominator here, it's got to be in the denominator out here. So that's 1/2 times the integral from 1 to 9. And then what I'm going to do is I'm going to take this u to the negative 1/2 and distribute it to both of those. Right? The 2 is already gone. It's out here. So I'm just left with u plus 1. So I'll distribute that and get u to the, let's see, if I add the exponents, a negative 1/2 plus 1, that's a positive 1/2. And then when I distribute here, I get plus u to the negative 1/2 du. And now I'm just going to add 1 to the exponent and divide by the new exponent. So I get u to the 3/2 divided by 3/2. Means I want to multiply by the reciprocal. Add 1 to this, I get u to the 1/2. Divided by 1/2 plus c. And I still have this 1/2 out in front, and we're evaluating from 1 to 9. Oh, I didn't need the c value, did I? And I don't need to write plus c because this is a definite integral, right? We're going to evaluate it from 1 to 9. I just got to make sure I don't forget my 1/2 that's out in front. Right? Now, remember, I said this earlier, you don't have to put the 2x minus 1 back into the problem because we converted these over to u values. If you did want to put 2x minus 1 back in for u, well then we're still doing the integral from 1 to 5. Alright? It would still work. Alright, so let's see, if I plug in a 9 first, I'm going to get the square root of 9, which is 3. 3 raised to the 3rd power, that's 27. 27 divided by 3 is 18. No, I'm sorry, 9. So 9 times 2, that's 18. And then I put a 9 in here, and the square root of that is going to be 3. Times 2, that's 6 over 1. Minus what I get when I plug in the bottom number. So if I put a 1 in there, 1 raised to anything is 1. Times 2, that's 2, so 2/3. And then I put a 1 in here and I get plus 2. Alright, so let's see, I got 18 plus 6, that's 24. Minus 2, that's 22. Minus 2/3. Still got to multiply that whole thing times 1/2. So half of that would be 11. 1/2 times this, that would be 2/6, which is the same as 1/3. And so my answer is 10 2/3. And if you wrote that as 32/3, that's fine. I'm okay with that. So just to make sure that we're aware of this, and I got to say this now because of what happened last semester. You know, we had I think 11 different tests where people got zeros from, you know, doing some dishonest work. I'm looking for all of these steps as I correct this. All right, we shouldn't just pop this into our calculator and come up with an answer, you know, or show half the steps. We need to make sure and show the steps on where all this is coming from. Okay? You know, I gotta say this, you guys, please don't put yourself in that position where you're using, you know, something like Photomath, an app on your phone that does all the work for you, because I believe everybody who got caught cheating, the class did not end well. Okay, it did not end well. It's not worth it for that 1 or 2 answers to jeopardize the entire semester. You know, please don't do that, okay? It was not fun for me last semester. I did not enjoy that at all. All right. So this is called change of variable. We know we're doing this when our du has a variable, or I guess there is no variable here, but there is over here. I've got to do something with that x. And so we go back to our original expression here, solve for x, and then substitute that in. It makes it a little longer of a problem, but we can still do this. All right? Let's try another one. All right, let me have you guys go ahead and try this one. It's pretty similar to the last one we did. This is square roots in a different spot, but you guys go ahead and give this a shot. Okay? All right, so I'm going to rewrite this as the integral from 1 to 4 of, in parentheses, I've got 2x plus 1 raised to the 1/2 power. I've got x and dx over here. So I want to let u equal what's on the inside of the parentheses raised to an exponent. So u equals 2x plus 1. So du is going to be 2, and I just took the derivative of x. So I'm going to need a 2 right here, and a 1/2 out in front, but the question is, what's going to happen to that x? Right? So let me go over here and solve this. I'll bring the 1 to the other side, so I've got u minus 1 equals 2x, and so x is going to equal u minus 1 over 2. So that's going to go in place of the x variable, du is going to go in place of this, and u will go in place of this. So here's my new integral. I've got 1/2, and then the integral from a to b, but we'll get that here in just a second. So I've got u to the 1/2 times u minus 1 divided by 2. And then 2 dx, that's going to be our du. So now I want to go back and use this to change my boundaries here for this integral. So if x equals 0, so if I plug a 0 into here, I get 0 plus 1, that's 1. So when x equals 0, u equals 1. And then if I put a 4 in, that'll be 8 plus 1, that's 9. So when x equals 4, u equals 9. And so now I'll bring this 2 out in front. It's in the denominator here, so it's got to be in the denominator here. So that means I've got 1/4, the integral from 1 to 9. And I've already moved the 2 out, so when I distribute this, I get u to the 3/2 minus u to the 1/2. Now we're ready to solve our integral. So add 1 to the exponent, this will become u to the 5/2. I got to divide by 5/2, which means I'll multiply by the reciprocal. This will become minus u to the 3/2 divided by 3/2, and we're going to evaluate that from 1 to 9. Multiply by 1/4 when we're all done. Alright, so if I plug in a 9 first, I get the square root of 9. That's what the denominator here does. Square root. So that's 3. 3 to the 5th power. Oh, geez. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Times 3 is 243. So I've got 243 times 2. I'm going to write this down. minus, let's see, when I plug in a 9 here, I'll take the square root and get 3. Raised to the third power, that's 27. Divided by 3, that's 9. So times 2, that's 18. Minus what I get when I plug in a 1. 2/5 minus 2/3. I still got to multiply by 1/4. All right, oh boy, this is messy. So that's going to be 486 over 5 minus 18 minus 2/5 plus 2/3, and the whole thing times 1/4. All right, well, I don't really want to try and do all that by hand, so I'm just going to throw it to a calculator. So let's see, if I'm using the TID4, I've got 1/4, I'm just going to call that 0.25, times, inside parentheses, I've got 486 divided by 5 minus 18 minus 2 divided by 5 plus 3 divided by 2, close parentheses. And I hit enter. There's what I get. If I want to convert it back to a fraction, just so I have an exact answer, I can go math, and remember that convert to fraction option on our TID4? I'll go ahead and use that, and what I get is 298/15. There's my answer. All right, let's try one more. All right, you guys go ahead and see if you can do this one. All right, so let's see. First thing I'm thinking here is let's rewrite this. So I've got the integral from 1 to 6 of x plus 3 raised to the negative 1/2. And then here I've got 2x minus 1 and then dx. So if I let u equal what's inside the parentheses being raised to an exponent. So there's no exponent here. I mean, there is, but it's 1. And so I'd rather go with the messier exponent. Right? So x plus 3. And that means that du is going to be, derivative of this is 1, and I just took the derivative of x. So that's nice. I could put a du straight in place of this. I don't have to worry about any additional numbers. But I still have something different here that I'm going to have to deal with. Right? What is x equal to? Well, let's see. X, if I move that 3 over, I've got u minus 3 is equal to x. So I can put a u minus 3 in place of this right here. So let's set up our substitution. So I've got this integral. We'll figure out what's going to go here in a minute. I've got u to the negative 1/2 times 2 times u minus 3 minus 1 and then du. So let's see, to change these numbers, I'd say, okay, when x equals 1, if I put a 1 in here, u is going to equal 4. And if I put a 6 in here, 6 plus 3, that's 9. So when x equals 6, u equals 9. Now we just got to simplify all this stuff. Right? So if I have the integral from 4 to 9 of u to the negative 1/2 times, let's see, if I distribute that 2, I get 2u minus 6 minus 1. So what I really have is 2u minus 7. Now I think we're kind of getting back to what the last two problems look like. Once I distribute this, I've got 2u to the negative 1/2 plus 1, that'd be a positive 1/2. And then when I multiply here, I get a negative 7u to the negative 1/2. You know, one common mistake that people make is they get this whole thing simplified and they think they're done. They've done the integral. But you haven't done the integral until you add 1 to the exponent and divide by that new exponent. That's when you quit writing the integral sign in the du, right? The moment I add 1 to the exponent and divide by the new one, I've done what these two things intend us to do, and then I just take them away. The same way, like if I say the square root of 4 equals 2, well, I've done what the square root symbol intended me to do, so I don't need to keep on writing it down. All right, so I'm going to add 1 to the exponent, so I've got 2u to the 3/2. And so now I need to divide by 3/2, which means I'll flip it over and multiply by 2/3. Minus 7, if I add 1 to the exponent, I get u to the 1/2, divided by 1/2, and evaluate from 4 to 9. If these numbers weren't here, if those numbers weren't there to begin with, then I would just write plus c and put my x values back in, right? All right, so let's see. Plug in a 9 first. So I got the square root of 9, which is 3. 3 raised to the 3rd power, that's 27. 27 divided by 3 is 9. And 9 times 4, that's 36. When I put a 9 in over here, square root of that's 3. Times 2, that's 6. Times 7, that's 42. Minus what I get when I plug in a 4. So if I plug in a 4, the square root of that is 2. 2 to the 3rd power is 8. Times 2 is 16. Times 2 is 32 thirds. And then plug in a 4 here, and you get square root of that's 2. Times 2, that's 4. Times 7, that's 28. Minus 28. Alright, so that's going to be a negative 6 minus 32 thirds plus 28. So what is that? That's like 10 2/3. So a negative 6 minus 10 2/3, I'll just subtract the 2/3 as well, and then plus 28. So really I got 28 minus 16. So that would be 12 minus 2/3, that's going to be 11 1/3. Or 34 thirds. Notice how I haven't written square units for any of these? These problems aren't asking me to find the area, they're just asking me to solve the integral, and so the solution is just some number. And there's that number. Okay. These are problems that you guys, if you're not checking in the back of the book, you could check on your graphing calculator. You could punch this in and see what answer it spits out. Okay. Make sure you check those. I noticed in the last homework as I was correcting it, I would see certain problems that the answers didn't quite look right. Some of them might have been evens. I don't think I gave you guys the even answers. So in your defense, that's not your fault. But if it's an odd problem and we're getting the wrong answer and we're not checking, that is your fault. Okay? We want to make sure that we check those answers so that we know if we're doing things right or wrong. We don't want to just do it and then when it comes to the test, boy, I hope I'm doing it right. I want to know, right? I don't want to just be guessing. All right, so there it is. That's integration using the change of variable technique. All right, that's what we have for today. So let me get you guys a homework assignment. All right, you guys, so this is assignment number 5, continued. We're on Wednesday's piece here. We're doing page 306. 53 to 71 odd. And just so you know, these take a little bit longer to get through. This is probably not something you want to put off until Wednesday evening or Tuesday evening when they're due. I would try and get these done ahead of time. Always shoot for Sunday as our day to have everything finished so we're ready to go for the next week. All right? All right, you guys, that's it. You guys take care, stay safe. I'll see you tomorrow on Thursday. All right, bye.